Question 3, the only change here is that we haven't quite been given the angle here. You could simply just find out what the angle was. If you just figured out what the angle, do the inverse tan of 3/4. And you figure out that alpha is 36.9. If you do that, the question's identical to the questions you did earlier. Let's work like that. So we've got 36.9 degrees here. We've got our 0.5 kilogram block there, pulling down with 0.5 g, and split that into its two parts, 0.5 g cos alpha and 0.5 g sine alpha. Normal reaction coming up, of course, there, and no other forces. So first of all, forces perpendicular to the slope is r minus 0.5 g cos alpha, and that's going to equal 0. So that gives me that the normal reaction here is 3.92 newtons. And then perpendicular to and then parallel to the slope, the acceleration going downwards here. So the force going downwards is 0.5 g sine alpha, and the force equals the mass times the acceleration. The mass is 0.5 a, and that gives me that my acceleration is going to be 5.88 meters per second. So if you didn't work out that, then what you could have just done is that if you've got a little triangle here and here's alpha, tan of alpha is 3 over 4, and that gives us that side over there, it's a 3, 4, 5 triangle. So you could have immediately known that cos of alpha was actually 4/5 there, and the sine of alpha here was actually 3/5. And that would involve not finding out what the angle was.